Today we're going to talk about circle graphs. Circle graphs are used when you are comparing a part to the whole. Each sector of the circle represents a category of the data and how it compares to the whole. A circle graph shows how each category of data compares to the whole using percents. The sum, or adding up all of the percents in a circle, is 100%. Circle graphs are easier to interpret or read when there are a small number of categories and when the percent values are not too close together. If you notice this circle graph in the picture, there's a lot of different categories. That would not be a good circle graph. Let's go ahead and answer some questions about this circle graph. This circle graph shows the pets of students in Mr. Wong's class, and there are 24 students total. So first of all, the first question is, what is the title of the circle graph? Well, the title is Pets of Students in Mr. Wong's class. Number 2, what are the different categories represented by the graph? The different categories would be the types of pets. So cat, dog, no pet, and other. Number 3, what percent of the class has a dog for a pet? Well, just by looking at the circle graph, we can see that 25% have a dog. So now what we need to do is figure out how many students that actually is. So what we want to find is 25% of 24 students. 25% of 24. If we remember what of means back a long time ago, of means multiply. So if we multiply 0.25 by 24, that's going to tell us how many students have a dog. And our answer is 6. So 6 students have a dog. Next question, what percent of the class has a cat for a pet? Well, that's 33%. And so how many students is that? What we do is we take 0.33 times 24, because there's 24 kids in the class. And that gives us kind of a strange answer, 7.92. Now, if we're talking about people, is it possible to have 0.92 of a person? No. So what we would say for this answer is, since it's almost 8 kids, but it's not yet 8 kids, we would say that 7 students have a cat for a pet. The next question, what percent of the circle is represented by all of the sectors? What percent for all of the sectors? So if we add all of the sectors together, what do we get? 25 and 25, that makes 50. And 17 and 33, that also makes 50. So that would be 100%. Why does this make sense? Well, because the total amount of a percent has to be 100. And the last question, would this circle graph make sense if the title or sector labels were missing? So pretending that we don't have a title, and we also don't know the category names. Would this graph make sense? Not really, because we don't know what it's talking about, and we also don't know what the categories are. That would not be a good graph to try to answer questions about. Okay, now let's take a look at another circle graph. This is Omar's typical day on a 24-hour day. What activity does Omar spend the most time on during a 24-hour day? Well, looking at the circle graph, it looks like he spends most of his time sleeping. How many hours does he spend on this activity? Well, he spends 35% of his total day. So we need to calculate 35% of 24 hours. So he spends approximately 8.4 hours per day sleeping. Next question, how many hours does Omar spend at school and doing homework? Well, for this one, we want to combine these two categories. We want to know about school and doing homework. So together, they account for 40% of his day. So we would need to find 40% of 24. And so this gives us 9.6 hours per day. And the last question, what percent of his day is spent eating? Well, for some reason, it doesn't give us the percent for eating. But what do we know about an entire circle? It has to add up to 100%. So we know he spends 30% of his time at school, 20% of his time on recreation, 35% on sleeping, and 10% on homework. This gives us a total of 95%. So how much time does he spend eating? What percent of his day does he spend eating? He spends 5% of his day eating. Okay, now it's your turn. Go ahead and pause the video, answer these questions about the circle graph, and then press play again to check your answers. Okay, the circle graph shows the grade levels of the students that attended the dance. Which grade had the most students attend the dance? That would be grade 7, because they had 40% attend the dance. If there were 300 students at the dance, how many grade 7 students were there? Well, 40% of the total number of students were at the dance, and so that makes 120 students total. Lastly, how many more grade 9 students came than grade 8 students? First, we need to calculate how many grade 9 students actually went to the dance, and then how many grade 8 students came to the dance, and then we can subtract them to see how many more. For grade 9 students, we know that 35% of the total number of kids went to the dance, and so that would be 105 students. Then for grade 8 students, we know that 25% of the total number of students went to the dance. That would be 75 students. So now how many more grade 9 students went to the dance than grade 8 students? That would be 30 total. Okay, one more chance for you to practice. Go ahead and answer the questions and then play the video to check your answers. Okay, let's see how you did. The circle graph shows the types of books that were signed out of the library during the summer. If there were 4,000 books signed out of the library during the summer, how many were teen romance? Teen romance accounts for 20% of the total books, so that would give us a total number of 800 books. Next question, how many books were science fiction or mysteries? Science fiction or mysteries account for 65% of the total number of books. So we need to take 65% of 4,000, and that equals 2,600 books. And the last question, what percent of the books are considered other? This is one of those questions where other is not given to us, and so we need to first add up the other percentages that we do know. 40% for science fiction, 20% for teen romance, and 25% for mysteries. That adds up to 85%. So if there's 100% in a circle, 100% minus 85% is 15%. Good job today.